All right, guys, we're going to start a little trig section today for the next several days, and hopefully a lot of it's a review from your geometry. But if not, you didn't do well, hopefully you get it this time. So here we go. Using trig with right triangles. Everything today is with the right triangles. The biggest thing that you probably remember from geometry is this word on the bottom there. I'm about to write it. SOHCAHTOA. All right, and that's how you spell it. I don't know if you can hope we can read my handwriting. SOHCAHTOA. Technically, you should pronounce it SOHCAHTOA because of the H's, but stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right. There's a picture up here of a triangle, right triangle. Make sure you know which sides are which. The two legs make the right angle. The hypotenuse is the longest side. It's opposite the right angle. It's right over here. The hypotenuse is the longest side opposite the right angle. And here's all of it written down in words. Sine is opposite over hypotenuse. And you, like I say, you should remember this. Now, hopefully you did these in geometry as well. You may not have. Cosecant is reciprocal of sine. Secant is reciprocal of cosine. And cotangent is reciprocal of tangent. Hopefully you did those. If not, we'll be working on those too. So they'll become no big deal as we go. All right, the first thing to do is going to give you a right triangle and ask you to find the 6 trig functions. So they're going to ask you to find what is sine theta, that's supposed to be a theta, what is cosine theta, what is tangent theta, what is cosecant theta, what is secant theta, and what is cotangent theta. So all 6 of them based on that one triangle. Now, if you notice the triangle is missing a side, but it's a right triangle, so you need to do Pythagorean theorem to figure out the missing side. Here's what I know right now. I know 15 squared plus the missing side squared is going to be 17 squared. Just Pythagorean theorem right there. 17 squared is 289. 15 squared is 225. If I subtract those, I get 64. Take the square root, I get 8. So the missing side is 8. All right, so sine, and there's my theta right here. Sine is opposite over hypotenuse. So I'm going opposite, which is 15, over hypotenuse, which is 17. Cosine is adjacent, which means right beside it, over hypotenuse, 8/17. Tangent is opposite, remember TOA, opposite over adjacent, which is 15/17. All right, now, the great news on the bottom row here is they're just reciprocals. Remember, cosecant is reciprocal of sine, so you can just take the reciprocal. Secant's reciprocal of cosine. That's why I wrote them underneath these like I did. Cotangent is reciprocal of tangent, so it's just 17/15. Okay, so these are always paired together, these are paired together, those are paired together as reciprocals. Like so, even though it says to find 6, if you find the big 3, you can just take the reciprocals. All right, trig values of special angles. These are trig values based on the special triangles. If you remember from geometry, the 45/45s and the 30/60/90 triangles are special triangles. And this is going to sound bad, but I'm going to really need you to memorize these 9 right there. I'm kind of circling them, those 9. And I'm going to give you a way to do that in class. Really a couple of ways to do that tomorrow. Hopefully it makes sense. You don't have any trouble with it, but it will help you so much if you can just click those off pretty quickly in just a few seconds. And I think you'll be able to do that after tomorrow. So you might want to take a picture of that slide. Let me erase what I did just in case you want to do that. Good, a good time to pause the video, take a picture of that chart. You're going to need that chart like crazy, but it needs to be in your head, not just on your phone or on your paper. So, got to memorize some. Sorry to tell you. All right, solve this triangle. All right, gives you one side and one angle. So what we're going to do is we're going to use what we have to solve what we need. Now, what we need to find is anything missing. So I need to find big B. I don't know what capital B is. I don't know what small a is, and I don't know what small c is. So that's what I've got to find. Okay, the good news is capital B, or capital letters always stand for the angles, and hopefully you remember this also. Small lowercase letters represent sides. So angle B, you know that all 3 angles in a triangle add up to be 180. So I have a 90 already. I've got a 28 already. So if I were to take those 2 angles, add them up, and subtract from 180, I'm doing on my calculator right now. 180 minus 20 minus 28. Angle B is 62 degrees. Okay, that's the easy one to find. And really, they're all easy. I should be saying that. Okay, to find side A, what I'm going to do now is I'm going to say, okay, A is opposite the 28 degrees. And I do know what the adjacent side is. So I'm thinking, okay, opposite, adjacent. That's tangent. So I'm going to do tangent of 28 degrees equals opposite, which is A, over adjacent, which is B. Okay, to solve for A, I'm just going to cross multiply right there. multiply the fraction. So I'm doing 15 times tangent 28. Now, one thing you need to make sure before you just punch these in your calculator, you need to make sure your mode is in degree mode, not radian mode, because if it's in radian mode, that's bad news. So when I punch that, I get 7.98. So there's my A, 7.98. And if I'm my little C, C's the hypotenuse. And again, I'm going to use the 28, and I'm going to use the 15. All right, and C, when I'm looking at C, C is the hypotenuse, and I still have the 28 degrees, still got the 15. So it is the hypotenuse, B is adjacent, so I'm thinking, okay, adjacent hypotenuse, adjacent over hypotenuse. That is cosine. So I'm going to do cosine, 28 degrees equals adjacent, which is 15, over the hypotenuse, which is C. All right, now if I'm going to solve that one, look, a little bit more steps. I'm going to multiply both sides by C to get rid of the fraction, equals 15. So to get my answer, I'm actually going to do 15 divided by cosine 28 degrees. And guys, that's a pattern. Anytime you're, put this way, anytime your variable's on the numerator, you just multiply to get your answer. Anytime your variable's on your denominator, I'm going to divide to get the answer. Okay, so I'm going to punch in 15 divided by cosine 28 degrees. I'm getting 16.99. All right, we'll probably just go one decimal place there, but just want to show you that one. Okay, so hopefully, like I said, you've seen all this before, nothing new, no big deal here. We will work on it tomorrow like we always do, but again, hopefully you remember it from geometry. All right, so see you then.